Welcome. This is a second recording in software used for mechanism design. In this case, we're going to look at the GIM software again, and this time we're going to look at its synthesis capabilities. So if you'll open up GIM and follow along. So once again, here's our GIM software environment. We've got the workspace. There's some, of course, tools. I can turn the grid on or off. I can change the grid size. There's some other options here that I can play with as an aside as well. For this discussion, we're interested in the synthesis capability. Previously, we looked at creating a mechanism and then analyzing the mechanism. In that case, we create the mechanism and observe or determine the motion. In synthesis, it's the inverse problem. We are given the motion and we want to solve a mechanism. So here I've selected synthesis. By default, it always comes up with this window. It's a 4R mechanism. And it has some default dimensional characteristics given to it. Then this is the classic problem that you begin with. A 4-bar. Here we call this length a coupler. Maybe this guy might be the input length, the output length, the coupler. This is a coupler point. Here are the revolutes on the coupler. Here are the revolutes on ground. That's given by default, but I haven't really specified much. So when I look at the synthesis problem, there are classic three methods to doing the synthesis problem, and that's what we're about to look at here. Right now, they have us in this free synthesis mode. I'm honestly not quite sure exactly what they're referring to. But historically, there are three methods. There's precision points or precision position. There is solid element guiding. In the US, we typically call this body guidance. We're guiding a body. Here we're guiding just simply points. Here we're guiding a body. And then the third one is function generation. Let me refer to the three very briefly. In precision position, I'm moving this coupler point anywhere it might exist. I'm moving it through a series of exact points. I don't care about the orientation, but I just care about passing through that point. So if I wanted to maybe make something that would travel along this path, and all I cared about was traveling on the path, not the orientation, then precision points would be my selected method. The next one is body guidance. The method of body guidance is similar precision positions, except that it adds to the position along the path, it adds the orientation of the body. That matters. So we call that body guidance or solid element guiding. That's probably the most common method that we would use. The third one here listed is function generation. In function generation, I'm providing a functional relationship between two members of my mechanism, typically the input and the output. So I'll specify the input to move at a certain amount, and then I want the output to move at some other defined amount, okay? Classically, that's a classic problem, maybe used a little less now, but it's the third method. I would suggest that solid element guiding or body guidance is the primary method. And so I'll select it. I probably should have selected the others. So by selecting the body guidance or the solid element guidance problem, you can see right off the bat it gave me these pink bars. These pink bars are the body. So this pink bar represents the body. It's just a bar, but it could be anything you want. Let's say it's I'm going to move a cup of coffee around my desk. Maybe it's hanging on the wall and I want it to deploy out where I can drink it when it's nice and warm. I can represent the L cup with just a rigid body and even reduce that just to a line. So I've got three positions here given. If I were to do position points, see, I just have the points and there's three are given. And then finally, if I was given function generation, I would simply have the angles. I should have done that a minute ago. Okay, once again, back to body guidance problem. Now, when I do the body guidance problem, there's actually two approaches. And I need to find that. There's actually, a submode. I should have scrolled down. In the body guidance, there's several submodes. I can suggest three postures and then the moving coordinates, which he's calling moving. These are the coupler points. I would have called these the coupler pivots. So I can suggest the three positions, body positions, what he calls postures, and the coupler pivots. I can specify three postures and the fixed pivots, or I can specify four positions, four body positions or poses, position orientation. Probably the 3 position fixed or the 4 positions are the 2 most common. And that's the maximum that you're allowed in an absolute sense. So I can either choose 3 positions to represent my path or 4 positions. 3 positions in the ground pivots or 4 positions total. Let's first go to the 3 position and ground pivots. What this means is I can now freely choose these 3 points, these 3 body positions, and in addition, I can choose arbitrarily these 3 or these 2 ground pivots. Those are the things that I get to choose, and then everything else, and they even highlight here. Everything else is fixed by my problem. So let's do an example. Let's say I have I've got a little minivan at home, and I want to go kayaking with the family. So I'm going to build a little rack that will lift the kayaks from the ground. So let's say my minivan stands this high, right in this region. I want something that'll pick my kayak up, swing it up, miss the minivan, and then come on top. And I want to get a little carried away. I want to just lay the kayak down flat here, but then when it's up on the minivan, I want to sit it up on edge because I'm going to try to stack 3 or 4 of them up there. So that's my problem. I don't know if we'll come up with something, but we'll at least talk through it. So the first thing I'm going to do is I need to modify these, and my computer's a little slow. So I'm going to grab this point for the first one, okay? So I'm going to have it start here, and I said that it would start out flat. Okay, so this represents the bottom of my kayak, okay? That's maybe it's in a little bracket that I'm going to lay the kayak on, okay? And then I need a final position is going to be up on top of my minivan, right here, and standing up. And you can see the 4 bars going crazy. It's solving the solution as I move along, okay? And then finally, the third position, I don't care too much except that it doesn't hit my minivan when I'm lifting it. So I'm going to move it somewhere over here. Okay. And so far, I'm not getting valid solutions. Okay, let's say here. See that lifts it up over the edge of the minivan and around. And, the angle, I don't care. The angle can be various things. Let's say it's almost, let's say the angle is almost 45. I don't care. I just want it to stay, lift up and then flip over like so. Maybe I don't want it to flip until I'm close. So maybe I want to keep it here and then come up and then flip at the top. If I can choose that. Finally, I've got these pivot points. And I can choose. And so let's say I'm going to make this mechanism attached to the rear end of the van. I'm going to have some bracket coming out of the, my trailer hitch. So I could imagine a bracket. So it's going to be kind of low on the van. So I'm going to grab my 2 pivots and move them over here. Okay. So I'm going to put them right there. So now I've specified my input points, my input positions of my kayak. I specified where these ground pivots are. So these things could hook to the back end, kind of down low on my minivan. And it actually gave me a solution to the mechanism. So I can now animate and see the solution. Okay, so here's how it would work. It's going forward. Let's start. Okay, oops. Okay, so it would start here. It would grab my kayak, and notice it'd have to go the other way because that's position. Ooh, I did them in the wrong order. Anyhow, that's position 3. I next want to go to position 2. So you can see this doesn't work. First thing it does is shows my kayak down into the ground, into the driveway. Finally, it gets up here. Then it carries it up. Now that looks pretty good. Oops, that looks pretty good. It's carrying it up to the second position and then standing it up right where I want it. Okay. So it goes through all 3 positions. That's good. It looks somewhat reasonable. I mean, I'm going to have to probably do some work on it, but not completely unreasonable. But it definitely is unreasonable in terms of digging my kayak down into the ground. So I now have the tool I now need to start modifying. So those 3 positions represented the path. I need to start changing things. I can start moving the pivots around a little bit, maybe find something happier. And you can actually see the path now. Now that you see it, and you see these lines representing where it goes. So I can start moving around and seeing where could I find something that would be a little friendlier to this, you know? Do I have to start the way I suggested or so on, okay? Now, right there, if I were willing, maybe this is a better solution. If I were willing to let the kayak sit at a slight angle when I first put it on, which seems okay, look there, I could pick it up in those 3 positions. And I don't care about that extra motion. I don't do that. I'm just going to start here. I set it on, and it picks it up and takes it to the top. Look at that. Oh, you know what? There is an error there. There is a mistake there. I'm going the wrong way. It's going to the first position before the second. So that's not quite what I wanted. Plus this reaches down below. So I'm going to carry on with this process. Carry on. Trying to find something that I like. So, you know, I can move these things around. I wasn't that picky. I just knew the general motion that I was after. Maybe it's going to come out a little bit. What about there? So you can see my procedure. Okay, let's try that one. Let's see what that one does. Okay, there we go. So here's another possibility. So my kayak starts at a slight angle. It starts driving up to the next position and then stands it in place. This solution actually looks pretty good, except for one problem, which is right down here, my mechanism at the first position, my mechanism is down digging into the ground. So this is the process I need to kind of work on. I'll have to go through this procedure and try to find a workable solution. It's iterative, but, you know, given if I said, well, this is my job for the morning, you know, I gave myself some time. I've got the tool. This is the tool that I would use to synthesize that. There are multiple infinities of solutions you can see, so lots of solutions. Really, the issue is just taking the time to dig through the solution space. Now, I do want to show you one other thing I noticed. Look here, I've got a solution. Then I go to a position like this. What does this mean? Well, this is a problem here. If those paths are not connected, it means that it actually can satisfy these 2 positions in one branch and this position in another branch. That's known as branch defect. You can see it when I start running the mechanism. Look, it goes through those 2, but not the other. I have to change the branch. There's a place to do that here. We'll just have to find it. Oops. Oh. Yeah, they're showing the crossed. See, the cross shows the other. That's the branch or the cross. That's what he's talking about here. There's a way to flip it to the other. Okay, see, this crossed is the other, what I call the branch, or he's calling it the crossed branch, and it shows it or not. There, that's the other solution. Ignore those at the moment. So you can see if I start running it, I thought there was a way to flip it too. You can see the mechanism reaches 2 of the positions in one branch, and then one of the mechanisms in the other branch. So that's a branch defect. That's no use to me. I can't. The way you get from this branch to this branch, you have to physically disassemble the mechanism and reassemble it in the other configuration. So that's not useful to me. So I need to look for solutions that match into the same mode. Anyhow, this is the tool. It's very powerful. This is the primary synthesis tool we use for mechanisms. This works for 4 bars, but it can work for the sliders or other four bars, although he's only showing this. So this is a primary strategy we'll use. I encourage you to use this more. Okay. So that will complete our synthesis discussion using GIM.